This video is going to look at the topic of isomers for alkanes and alkenes. Now I've drawn out here the first four alkanes, which you should now be able to name. So we've got methane with 1 carbon, ethane with 2 carbons, propane with 3 carbons, and butane with 4 carbons in the chain. Now, the first 3 alkanes, methane, ethane, propane, there's only one structure that you can have for them. There is no other alternative. So with butane, there's more than one structure that you can have. Now, one option is to just draw straight butane with 4 carbons in a chain. Another option is to move this group here and switch it over with one of the hydrogens in the middle. So if I draw that one out now, so we've got 3 carbons in a chain, so these first 3 here, but I'm switching this carbon and this hydrogen over, we can have a slightly different structure. It still has the same number of each type of atoms in it. It's still got 4 carbons and 10 hydrogens. So it's still got the same molecular formula, but this time we have a slightly different structure. Now this structure is called 2-methyl propane. Now the reason for this, we've got 3 carbons in a long chain. That's where the propane comes from. Just like propane has 3 carbons in one long chain. But this time, off the side of that chain, we've got a different group with 1 carbon in it. So it's a side group, which is a methyl group. Now that's carbon 1 and that's carbon 2. So that's where the number comes from to give it 2-methyl propane. Now these two structures, they have the same molecular formula, but they have a different displayed formula or a different structural formula. So here it's absolutely vital that you learn this definition. Structural isomers have the same molecular formula, but a different structural formula. In our next example, we're going to have a look at the isomers of pentane. So, if we have a look at the first example here, we've got one straight long chain here with 5 carbons in it. So our molecular formula here is C5H12. If we have a look at our second example here, this time we've got 4 carbons in a long chain, and then we've got one side group here off of that main long chain. So this one, on the second carbon, that's carbon 2, that's carbon 1, 2-methyl butane. So we've got the butane part from 4 carbons in one long chain, and then 2-methyl, so off the second carbon here, we've got our methyl group. If we look at the molecular formula is exactly the same. It's got the same number of carbons and the same number of hydrogens. So they fit our definition, same molecular formula, but a different structural formula. Now you might be wondering, well, what would happen if I moved this methyl group and switched the 2 over? So I put it there instead. This doesn't actually change the name at all. Now, instead of naming this as carbon 1, now you would just simply name this one here as carbon 1. So this would be 1, this one's 2, this one's 3, and now this one's 4. Now the reason why you do this is because the molecule is actually rotating. So this molecule is rotating around and spinning over. So no matter where you draw it on this molecule, if you draw it there or there, it's still on carbon 2. Now if we look at alkenes, again, we can have structural isomers of them. Now, for the first 2 alkenes, so ethene and propene, again, there's actually not going to be any alternative structures to these as alkenes. There are alternatives that you can study at A-level, but here focusing at GCSE, there is no other structure that you can have for either of these 2. Once you start getting 4 carbons again, we can now have a different structure. Now, in this situation, we've still got the same molecular formula. So we've got C4H8 is the molecular formula of butene. But this time, we can have the double bond in a different position. So in this example, on carbon 1, that's where we find our double bond. But we can switch these 2 over, and we can have the double bond on the second carbon in butene. So if I just draw out now butene, another example, Now in this example, we've still got the same molecular formula, it's still C4H8, but now our double bond is on the second carbon in the chain. So this one is called but2-ene, and that's because our double bond is found on the second carbon here in the chain. And again, it doesn't matter which end you start from. If you start from this end, it's still going to be on carbon 2. If you start from this end, it's still going to be on carbon 2. So if this is but2-ene, that means this one should actually be called but1-ene, because the double bond here is found on the first carbon in this chain. So all you have to do is choose an end to number from, and keep the number as low as you possibly can. So I hope that helps you look at alkenes and alkanes. There is a lot more that you can look at on this topic, but this is just an absolute basic introduction.